Hello, this is Tyler Beamer, Hayward Community College. It's an instructional math video for DMA 040. This video is in regards to Module 4, Section 10, Solving Linear Inequalities. Okay, so an inequality is a statement where things are not equal, hence the prefix in. So we can have less than, greater than. We could also have a combination of an inequality and equal sign in less than or equal to, or greater than or equal to. So you see you have an inequality and then a line underneath. It's kind of like combining an equal sign and an inequality together. Keep in mind which side of the inequality is which. The pointy side is the less than. The mouth is the greater than. So just keep those two straight. So here are examples of inequalities, and we're going to look at how to solve inequalities that look something like this. Alright, so when we solve inequalities, it's different than when we solve equations. When we solve equations, we generally just have one solution. When we solve inequalities, we have multiple solutions. So it's actually easier for us to show the solutions by graphing. So we use a number line to graph. We use a closed circle at the endpoint for less than or equal to or greater than or equal to. And that basically implies that that endpoint is also a part of the solution. So here's an example of that. X is less than or equal to 7. Right, so then we're actually going to have a closed circle at 7 because 7 is part of that solution set. If we are just using less than or greater than, we actually use an open circle, such as this, and that would imply that the endpoint is actually not part of the solution set. Okay, so let me show you a couple of examples here. When we're graphing inequalities, it's always most beneficial to write them with the variable on the left-hand side. And if we do that, the inequality actually then points the direction that you should be shading. So here's -4. So since this is greater than or equal to, I close this, I include this endpoint in my solution. And then I want to shade the numbers on the number line, or point to the numbers on the number line that are greater than -4. So that's going to be to the right of -4. And you can see if I write my inequality with the variable on the left-hand side, the inequality actually points in the direction that I should be shading. Okay, so if we had this, all right, open circle at 1. And then we would shade to the left, to the numbers less than 1. Notice the inequality points the direction I should shade. But that only works if the variable is on the left-hand side. So how do we rewrite that inequality to make it so that it's on the left-hand side? So if I look at this, I've got 5 greater than x. I want to rewrite that so that x is over here on the left, 5 is on the right. So this inequality still needs to match up, which means the greater than side still needs to match with the 5, less than side needs to match with the x. So the inequality is actually going to reverse. These two are equivalent. This is a much easier way to interpret this because this is in regards to my solutions. X is less than 5. My solutions are less than 5. That makes a lot more sense. And it also points in the direction that I would want to shade. So those are some things to keep in mind here when we're looking at graphing inequalities. Alright. This is what we call a compound inequality. It's actually two inequality statements combined into one. So if I cover up the left-hand side of that, I get the first inequality statement, x is less than or equal to 5. And so if I want to graph that, close circle at 5 going to the left. Okay. If I cover up the right-hand side, it gives me the next inequality statement. Right? -2 less than x which I would want to switch that around so that it is written with the variable on the left. So negative 2 greater, or I'm sorry, x is greater than negative 2. So open circle, shading to the right. And so we're looking for numbers that essentially meet both criteria, meet this criteria and this criteria. Therefore, we're looking at the numbers that are between negative 2 and 5. So then the graph would actually look like this. These are all of the numbers that meet both of those criteria, numbers that are less than or equal to 5 and also greater than negative 2. So that's how we graph compound inequalities. Okay, solving inequalities. That is a big emphasis of the section. So when we solve inequalities, we solve them much like equations, except for one difference. If you multiply or divide by a negative number in the solving process, the inequality must reverse. So let's look at exactly what that means. So if I divide by a negative, right, that means the negative is going to be on the bottom of this division. So this would be an example of where I would reverse the inequality. Okay, I'm dividing by negative 2. Okay, I would not reverse the inequality here. I'm dividing by a positive 2 into a negative 4. So it's only when I divide by a negative. And the reason being is that changes the sign, and of course larger negative numbers get smaller in value. Think about your bank account, right? Would you rather see negative $500 or negative $5? Right? Negative 5. So that's why we have to reverse that. Okay, so for example, if I was solving this inequality, right, imagine this was an equal sign, right? I'd solve it by dividing by negative 4. Since I divided by a negative here, this inequality is just going to reverse, which basically just means it's going to switch, and that would be my answer. Okay. If I had this, I would not change the inequality because I'm not dividing by a negative to solve. Even if I had this, I would not change the inequality because once again I'm dividing by a positive 4 here to solve. Right? The sign is not changing on this side. So I'll only change it if I'm dividing by negative or multiplying by a negative. Now multiplying by a negative is obviously easier to determine. The dividing is the part that really kind of throws people for a loop. What happens is that people just start changing the sign every time they see a negative sign, and that's not the case. All right, so let's look at this example. Okay, 3x plus 8 is greater than or equal to 5. So if that was an equal sign, we want to solve it the same way, right? So we would use our adding, subtracting inverses. Okay, divide. In this case, I'm dividing by a positive 3, so the inequality does not change. So it stays the same. And then, of course, if I wanted to graph this, I'd find negative 1, close dot, since it's greater than or equal to. Since I've got my inequality written with the variable on the left, it points the direction that I need to shade, which would be to the right. Okay. This is a little more complicated inequality, but you have solved equations similar to this, so treat it the same way. So simplify both sides. I can distribute on the right hand side to simplify it. And then I always recommend when you're solving inequalities is to isolate x by bringing x to the left, because you want to have that inequality written with the x on the left hand side anyways, because it's easier to interpret when graphing. So let's go ahead and just follow through with that now. Okay, so subtract 5x from both sides, then subtract the 9 from both sides. Then divide both sides by -2. And since I'm dividing by negative here, right, that bottom number is negative, I've got to change the inequality. So then it would be x is less than or equal to 7. So here's 7, close dot, going to the left. Okay. Alright. So once again, simplify each side just like you would solve an equation. So we can distribute here, combine the like terms. Okay, so that gives us 8x minus 14 on the left-hand side. Simplify the right-hand side, minus 20 plus 4x minus 12. Okay, so then I can combine the like terms once again, so 4x minus 32. Okay, then get the x isolated. Like I said, I'd bring it over to the left-hand side. So 4x minus 14 is greater than -32. Use your adding, subtracting inverses here. Okay. So then we are going to combine those. Divide by 4. And since I'm dividing by a positive, even though I'm dividing into a negative, but I'm dividing by a positive, I'm going to keep the inequality the same. I'm not going to reverse it. 4 is not going to go into 18 evenly, so we would write that as an improper fraction. We can certainly divide both of those by 2. So we get -9/2, which would be -4.5. So open circle at 4.5 going to the right. Okay. And here's an application. So you're having a catered event. You can spend at most $1,200. Okay. So at most means it has to be less than $1,200. So the setup fee is $250 plus $15 per person. So find the greatest number of people that can be invited and still stay within budget. Okay. So then the cost needs to be less than $1,200. Okay. And the cost is $250 plus $15 per person, and X represents the number of people. And that's what we're solving for. So subtract the 250 from both sides. Divide both sides by 15. And you get 63.3. So obviously we can't invite a 0.3 of a person. So we can invite, really this can be less than or equal to, so less than or equal to 63 people. All right. And that would get us pretty close to our budget. Okay, so hopefully this gets you a good start with solving linear inequalities. If you have any questions, as always, please email those to me or come by office hours. Have a great day.